In this video, we're going to be writing the partial fraction decomposition of a rational function, and this is going to have repeated linear factors. So here we have 5x squared plus 20x plus 6 divided by x to the third plus 2x squared plus x. Now the first thing that we want to do is take a look at our denominator, x to the third plus 2x squared plus x, and we want to factor it. So when we go to factor that, we see that there's an x that they all have in common, so we can take out an x. So let's just actually write this like this so that we can see where it all goes and how it moves. Okay, so again, we're going to take out an x, and that leaves us with x squared plus 2x plus 1. And this portion right here, that can actually continue to factor. So we're looking for two numbers in this case that would multiply to 1 but add to 2. And 1 and 1 will totally do that. So that means we have x, and then we have x plus 1 and x plus 1, which really means we have x and x plus 1 quantity squared, right? Because we have two of those. We have that repeated fraction. So now we should include one partial fraction with a constant numerator for each power of x and x plus 1. So that means what we're going to write next is we're going to have a over x plus b over x plus 1 plus c over x plus 1 quantity squared. So now we want to get a common denominator, right? So our common denominator, so our least common denominator, is x times x plus 1. So we want to multiply so that we get that, right? Or excuse me, x times x plus 1 quantity squared, okay? So that would mean over here, we would need to multiply by an x plus 1 quantity squared to the numerator and the denominator. And over here, we need to multiply by an x times x plus 1 to the numerator and the denominator. Then over here, we just need an x. And we do that because we want to be able to cancel out the denominators. See, now each denominator is going to be the same as an x times x plus 1 quantity squared. So that's going to cancel out. And that's going to give us our a times x plus 1 quantity squared plus b x times x plus 1, and then c x. All right, so from here, we're going to need to distribute. But first, because we have this portion right here, right, we actually kind of need to take that and FOIL that out. So x plus 1 times x plus 1. So that's going to be x squared plus x plus 1, or x squared, plus 2x plus 1. All right, so now we're saying that we have a times that x squared plus 2x plus 1 that we just multiplied, plus bx times x plus 1 plus cx. And we're going to distribute that a value out, right? We're going to distribute that a value. So I have ax squared plus 2ax plus a plus bx squared plus bx plus cx. So now we're going to group the things that are together. Now what do I mean by group the things that are together? So what I mean is that here we have an x squared, and here we have an x squared. Here we have just a plain x and a plain x and a plain x. And here we have just a plain like a. All right, so now if we group these together, now what we're looking at, okay, is we're looking at the fact that we have an a plus a b x squared, right? Plus, we've got this 2a plus a b plus a c, and those are all times the x. And then of course we have our plus the a, right? So we've grouped these together. So equating coefficients of like terms on opposite sides of the equation is what we're going to do next. And that's going to give us, let's see, let's put, so what we're saying is that we've got that 5x squared plus 20x plus 6, right? So we're equating that. We're putting those kind of together. So what we're saying here is that we're going to have, let's see, let's use this. So our x squared here goes with our x squared here, and our x goes with our x, and our constant goes with our constant, right? And so we're going to set this up as a system of equations. We're set it up as a system. So it's going to look something like this, right? So in the purple, in the x squared, I can say I have a plus b equals 5. And I can do this in the purple so that it's a little bit easier to follow. Okay, so we have our a plus b, and that equals the 5. Okay, then we've got the 2a plus b plus c, and that equals 20. And then we've got a, and that equals 6, right? So this right here is our system. And now we can solve this because we can use some back substitution. So as I look at this, I'm going to see that if I know that a is 6, I can just plug that in right here, right? So using my back substitution, if I have a plus b equals 5, I'm going to replace my a with the number 6. And then from there, if I subtract 6 from both sides, that's going to tell me that b equals a -1. Okay, so that means I have what a is and what b is. So now I can plug that into the third one. So I can say, okay, 2a plus b plus c, and that's supposed to equal the 20, right? Okay, well, we know what a is. We know that a is 6. And we just found, oops, I tried to write the b. We just found that b was that -1, right? B was the -1. And now we've got our plus c equals 20. So we're solving for c here. So we have 12 minus 1, really, right? -1 plus c equals 20. I'm going to move this up a little bit, give us a little more space. So now we have 11 plus c equals 20. Subtract 11 from both sides, and that's going to give us a 9, right? That's going to give us a 9. So now we have our 3 answers, right? Our 3 pieces. We've got the a equals 6, the b equals 1, and c equals 9. Okay, so what do we do with that to write our final answer? Because we're writing it as a partial fraction decomposition. All right, so what that means for our final answer, I'm going to go ahead and put it right here, is that we're going to have that, let's see, 5x squared plus 20x plus 6 all over x to the third plus 2x squared plus x equals 6 over x minus 1 over x plus 1. Let's scoot this over a little bit. Plus 9 over x plus 1 quantity squared. Okay? And that's going to end up being our final answer. So notice that we took the a, we put the a in the a spot, and the b went in the b spot, and the c went into the c spot over our pieces, right? And that gave us this final answer right here. And we're done.